Okay. Yeah, well, welcome all. Thanks. Nice to see you again. If I haven't met you, hopefully we'll have a chance sometime down the road to actually shake hands. So yeah, let me share my screen first of all. And got to pull up the slides here. Hopefully you can all see that.
Looks good.
All right. Got the official Iowa template here. So I think that's pretty cool. Got the colors going. Team's not doing as well as I would like, but it's the way it goes sometimes. Yeah, as was mentioned, I'm typically doing aerosol related research of one type or another. And I guess this is somewhat related, although it's getting further out in the field, literally. And this came across by way of a suggestion associated with this IFV notation I'll describe, and how it doesn't seem to be samplers that satisfy it. So that was the impetus behind it all. I managed to get 2 master's students through their required thesis talking about this or diving into it. So Shawnee Alex and Matt Sovers took on various elements of this. I want to acknowledge their work up front. And feel free to just interject with a question if you want to. I'm going to try to rip through this fairly quickly and leave you some time for questions afterwards if I can answer them. So you're all aware of pesticide application here in the Midwest, of course. When I came here from Vermont, I was just astounded here. I called it agriculture on steroids around here. It's just amazing. But yeah, of course, this is done all over the country, all over the world. Billions of pounds of pesticides. Obviously, agricultural workers are mostly involved with this, but there are others, and right down to the home level. There's a guy using a backpack with kind of a fog sprayer type of operation here in what looks like a vineyard, probably in California, actually. So the health risks, both acute and chronic, go from simple airway inflammation, with the resulting coughing and wheezing, the headaches, to some chronic things, especially insecticides, right? We all know that they're going to be that much more toxic than an herbicide. So get into central nervous system problems. They're starting to link up certain insecticides, especially with Alzheimer's and types of dementia. So that's not good. And the factors affecting the exposure, of course, are going to be associated with the application method. I'll talk a little bit about whether or not they're using any PPE or not, and then there's going to be environmental factors, just the meteorological conditions at the time. Hotter is going to cause more evaporation, for example, and back to the method, how much of a broadcast they're giving to the spray, and that sort of thing. It's going to obviously affect exposures, which also makes it that much more difficult. Anything outside, as you all know, is going to be that much more difficult to get a good handle on actual exposures. And, these things are engineered systems, right? These nozzles are not just thrown together. There's years and years of development on the nozzle itself relative to actually the liquid's vapor pressure and other qualities of the liquid that allow it to get a nice spray coming out of that nozzle for a certain amount of back pressure that you can pump into the sprayer. And so obviously it's going to obviously eject a droplet of some size type. And then the whole goal, of course, is to get it to stick to the plant and stay there. As shown here, the backpack type sprayers and handheld sprayers tend to put out a smaller droplet size than the large commercial operations like you see down there at the bottom. But a lot of this type of ATV related little boom sprayers in the back are fairly common now to go out and spot spray, or say for ball fields around town or golf courses, that kind of thing. It's used quite a bit nowadays. So you can see in this case, a guy's riding it. He's in front, the spray's in the backs, but wind can push it in his direction. Although I have seen some enclosed kind of gators now that they can utilize for that as well. So just to get into the physics a little bit of this, because kind of starts the story behind this IFV notation. So there's a group of compounds called semi-volatiles, and they truly are that. They're kind of volatile, kind of not. They have vapor pressures that are, as you can see here, 10 to the minus 14 to 10 to the minus 4 atmospheres, whatever that means, but I kind of show you here by comparison. Water is 3.3 times 10 to the minus 2. So these SVOCs are less evaporative than water. They want to stay as a droplet. And this is the range of most insecticides. So if you spray a semi-volatile organic compound, you're going to obviously have a droplet. That's known right up front because that's what is coming out of the sprayer immediately. But you're going to have a vapor as well. And here are some vapor pressures of some pesticides that is put together here along with the TLVs and potential PEL or RELs associated with them. As I'm finding out too, the more I learn about this business, so to speak, the more I realize that a lot of these types of what were common even 10 years ago are either gone now or certainly have found replacements. Like the last one here, chlorpyrifos, is, I believe, has been axed in this country. Alachlor as well, dieldrin. Most of these I'm showing here actually have seen the end of their days. So I'll bring that issue up as well as we go along. So now on to this notation that the ACGIH came up with called the Inhalable Fraction and Vapor Endnote. So you open up your TLV BEI book and you look up chlorpyrifos and you'll see this little IFV notation on it. They have a brief description of it in the TLV book and not much else information. So what it does say is that the material exerts, quote, sufficient vapor pressure that it may be present in both particle and vapor phases. So as you go down through that listing in the TLV book, you'll see that majority of the pesticides listed in the TLV book, if it has a TLV, it'll be in the book, first of all, and then it'll probably have this IFV notation on it, which means it has that vapor pressure in that range that I showed earlier. So again, getting back to the physics, sorry if you know all this stuff, but just to remind ourselves. So this thing called the saturation vapor pressure. So you put a liquid into a jar, close the jar up, it'll start evaporating in the jar and it'll exert a certain pressure within the jar space, the airspace, up to some point where it just can't exert any more pressure. And so that's the saturation vapor pressure. And you can see from this diagram that there will be an increase in that pressure, obviously with an increase in temperature. So you always have to refer to the temperature if you ever give a number in association with this saturation vapor pressure. But there is also going to be a coincidental concentration that will result at this maximum possible pressure. So that's called the saturation vapor concentration. And it's going to be nothing but vapor. It's just whatever the vapor inside there is exerting and the resulting concentration from it. So for example, we got a sprayer here, and this is a rice paddy, by the way. So this is another country altogether, thank goodness, in terms of the fog spray that's being produced here. So again, you're going to have the droplets exit the spray nozzle as droplets immediately, but it won't take long for a mist to develop that is going to be a combination of the slowly evaporating droplets and the vapor from the evaporated droplets. So this is kind of what we're talking about. So if we want to get at a total inhalation exposure of this worker, we have to get at both of those phases, as they're called, both the total concentration and the concentration of droplets in the vapor. So that's where we're kind of getting towards here with this IFV notation. Now, just to bring this back again to this saturated vapor concentration, and now we're kind of relating it to the typical range of concentrations out there, which the TLV should be kind of a maximum of those typical ranges, right? But it gives you kind of a ballpark of what you would expect would be the TLV concentration. So the ACGIH decided, let's compare this saturated vapor concentration to the TLV. And if it's really low compared with the much higher level of the TLV, which is kind of a weird concept, but then you'd expect then that most of this compound would be in the form of droplets, because you've already maxed out its maximum possible vapor concentration, and you still have more to go to get up to the TLV, right? So it must be mostly droplets then, if that makes sense. And then just the opposite, if the SVC is much higher than your concentrations, those around the TLV, then it must be mostly vapor. So if you had the first case, you would go out and sample with a filter of some sort, because they're just all droplets. They are not evaporating very much, if at all. And then, of course, if you're mostly vapor, you would go out and sample with a sorbent tube and get the total concentration you're looking for. So drum roll, please. Back to the IFV Endnote. There was this concern that there are these compounds that are, have this kind of sweet spot, as I'm calling it here, of the saturation vapor concentration. Is not too high to be all vapor, and it's not too low to be all droplets, right? So that's what it's all about. And so they decided, just to try to get a little numerical about this, to create this ratio of the saturation vapor concentration to the TLV. And if it's in an order of magnitude plus or minus 1, 0.1 to 10, then we'll call it that this compound deserves to be considered as something where you have to go out and have some sort of sampling device that gets at both the droplet concentration and the vapor concentration simultaneously. So again, above 10, you're going to be mostly vapor, and below 0.1, you're going to be mostly droplets. So that's the preamble to all this. As an example, getting back to chlorpyrifos, it's got a vapor pressure 1.9 to 10 to the minus 5th millimeters of mercury. Molecular weight, you can chuck it into this equation here to calculate the saturation vapor concentration and end up with 0.36. And this is at 25 degrees centigrade. That's where that 24.45 comes from. That's the volume of a 1 mole, just if you're curious. And the TLV is 0.1. So we compute that ratio, we get 3.6. So that's within that 0.1 to 10 range. Therefore, slap the IFV notation onto chlorpyrifos. Okay, so then there's the other aspect of this. It's the IF part, inhalable fraction. And again, the TLV book is a little vague on this. If you look at it, you really read it through. I'm using the word assumption because it doesn't state specifically, but it must be that it means that you need to have the droplet capturing device of this sampler to be an inhalable size-selective sampler, right? That must be used. And otherwise, you're not going to be accurately assessing the droplet inhalation. And then again, it's going to have some sort of sorbent media to capture the vapor. So that is, again, this was the question that was posed to me by Mike Murphy of 3M, actually, who's part of our aerosol technology committee from AIHA, and said, I don't know what's going on here, but this is what must be happening. It must be the assumption, but I don't see any work on this or any samplers associated with it, etc. So you all know what I mean by inhalable size selective. There's the blue line there. That's the inhalable curve. In this case, by the way, you can see the x-axis is a log scale, but it goes from about 100% efficient for the really tiny particles to 50% at the really, really super large particles that are just barely able to get into our mouth. So that's the type of sampler should follow a similar type of curve in terms of its what they call the aspiration efficiency. And we all know that the IOM satisfies that pretty well. Actually, I'm not certain as to whether that curve was developed because that's how the IOM behaved, or whether the IOM was developed to match the curve. To get back into that, it's an interesting story in itself, but I think it was a little bit of both, to be honest, with James Vincent waving his hands and having a napkin kind of thing going on and drawing a line through a bunch of points to come up with that blue one. But again, that's another story for another day. Anyway, so we have samplers that are inhalable and size selective. Okay, now let's go to the standard method for pesticide, because you want to go out there and start measuring it. Well, you're going to come across, at least for certain types, a broad range of pesticides. You're going to get to method 5600. And you're going to go down to the sampler here, and just to blow it up a little bit for you, you're going to see it says a filter / solid, okay, sorbent tube combination, which, oh, good, that's what we want. And then it says OVS-2 tube with a 13 millimeter quartz filter, XAD2, and these other numbers. Okay, so what does all that mean? Well, that OVS-2 is something that's been around. It is called the OSHA Versatile Sampler. And it was designed by apparently somebody at OSHA. I'm not sure about the history behind that. But it is the sampler required in both method 5600 and 5601, which are the primary two standard types that NIOSH came up with for pesticide sampling. But you can see down there below, it was certainly not designed as a size selective sampler. So this is what it looks like pointing upward. You buy it as a glass tube like this. It's got a filter on the top, and it's got the sorbent media behind it, exactly what you would expect and hope for. So the filter is going to capture the droplets, and sorbent media gets the vapor. And of course, as you're sampling, some of the droplets you've captured can turn into vapor as they evaporate while you're sampling as well. But all is well if you use something like this to get the total concentration. Now, it's actually used, it's inverted and put into a solid plastic casing like this. And so this is what would be clipped to a person's lapel. And you can see now that the actual aspiration of an aerosol into this thing has to come from the bottom up into the plastic tube and then finally into the glass tube. And so from this view, you can see that the filter is actually pretty darn far up in there in terms of its ability to capture droplets. So that's it right there. That's the standard. That's what you would go out with if you're going to do anything, especially OSHA related. Okay, so this again brought up the research associated with this, and our first question was, what is going on with this OVS? What is its aspiration efficiency? And possibly, if it's not that great, can it be altered to be an inhalable sampler? So that was the first goal. And for that, we didn't care about vapor. Okay, so all we care about here is aspiration efficiency is just any particle, really. How does it get in? What is the efficiency of it? And again, say relative to an IOM. So those are the two main study objectives here, to look at that efficiency and to see whether modifications could be done. Because assuming if this is already the standard device, then maybe something could just be tweaked on it to incorporate it to make it more of an inhalable sample, and then we're good. So we set up a system where we used the IOM as kind of the control device. What it says should be true in terms of inhalable. We used that kind of asbestos cassette there as an isokinetic sampler. We pointed upward and in our chamber to get what we consider to be total concentration. And then we have the OVS. Now the OVS, you see, has to be a maximum of 1 liter per minute. That's because of the sorbent media behind it. You don't want to go any faster than that. So we had this kind of a schematic of a chamber, and within the chamber, I don't know if you can see my cursor here, but we put in some 8-inch duct work inside this thing. So the chamber actually was just kind of a fume hood. And we were trying to get a nice laminar flow down through the column to the samplers below here. And then we had some graded, sieved inorganic dust with a known median diameter that we chucked into the top. And then we could sample, and this would allow us to get at the aspiration efficiency and also the comparison to the IOM. So you can see here actually the OVS is placed horizontally for one of the experiments when we tried it that way. Again, if I'm going too fast or you need to ask a question, you can just jump right in. Let's see, there's something in the chat. Okay. All right. So then we just analyzed again. We're comparing the isokinetic or the truth, the total aerosol, to what's being pulled in by the OVS, and then compare directly to the IOM. And for results, this is now the IOM performance. We want to make sure that our system behaved the way we would expect it to. And you can see for the 3 different dust types we had, the answer is yes, it performed pretty darn well relative to expectation. You see that dotted line is what they call the calm air curve, which is what we were trying to shoot for. And then this is these are the results for the OVS. So you can see we're just dropped off in terms of their efficiency to collect particles in that inverted manner in which the OVS is supposed to operate. So the answer, so here is no, this is definitely not an inhalable sampling device. And just to look at it another way, here we are relative to the IOM. So this is on efficiency relative to the IOM 100%. So, you know, if it was exactly like the IOM, it should be right there on that 100% line, where you can see here we're about a third of that using the OVS. So, so the OVS is not only off, it's pretty darn far off an inhalable sampler, which could be a concern, right? That we're undersampling, certainly relative to the inhalable convention. And then the next objective, whether we could modify things. And again, we had to try to mimic it's the inlet velocity is the key to inhalable, capturing that convention. It all has to do with that velocity and then the filter location. But we're at 1 liter per minute instead of 2, but the OVS opening, the diameter of it was almost perfect. So at 1 liter per minute, the inlet velocity of the OVS was almost exactly the same as the IOM. So right there, we're already real close to a possible fix here. And then we thought, hey, if we can just turn it horizontally like the IOM is, right? It's facing outward, not downward. That might help. And just to do a whole bunch of runs, Shawnee took the guts out of an OVS and chucked a Tygon tube in there as kind of a support behind the filter. And then she just weighed the filters off of this in between trials. So here's the normal configuration. And we tried 2 that were horizontal. Well, actually, she tried multiple ones, but I'll just talk about these 2 where we also put a plastic cap as kind of a flange opening and a plastic cap that was kind of a sharp-edged cone on it to try to enhance its aspiration efficiency. And the results were rather disappointing. You can see the green dots are the flange. So they somewhat above the normal configuration, but not anywhere near what we were hoping for. And I think the answer to this is that the filter also is still way deep in that tube. And that's a major part of this in terms of why it didn't get to the filter itself. Now, you know, we may have collected quite a bit within the glass, but we didn't measure that because we didn't wash the glass out right on the inside. And she also measured the IOM in 2 ways, you know, as with the cassette and just the filter itself to make that comparison maybe a little closer. But either way, we still had lousy results here. So that was her thesis, and so Matt came in, and at the same time, SKC came out with this thing called the IFV Pro. And so, as you can imagine, if you wanted to design this thing correctly, you would probably start with something that looks like an IOM type of sampler, right? And then put some adsorbent media on the back side of it. And that's exactly what they did. So this is what it looks like. That I should have had a ruler or something. That tube is about 6 inches long. So it's a pretty big device. You can see now, instead of pointing downward where the opening would be at your mid-chest height, now the opening is up high, near your shoulder. So that's also a good thing. Of course, it's facing outward, and it's taking this off. Of course, then you'd have the sorbent tube on the back side of it. So that's the IFV Pro. And so then it's a matter of what does it do? SKC apparently didn't have the wherewithal to actually do this kind of aspiration efficiency testing themselves. So as far as I know, this is the first work done to do that. And so just to give you a little, they had to reverse engineer the IOM head for 1 liter per minute rather than the 2 liter per minute. So it's just a matter of, similitude, as they call it in engineering, get these ratios down. And again, it all comes down to the inlet velocity. So knowing good old Q equals VA, and A is the diameter, we get at the diameter needed here to have the same velocity. So here's a picture of the 2 inlet heads. Now the one on the left is the IFV Pro, and one on the right is the IOM. So you start with the IOM, 2 liters per minute, go through the calculations, you end up with 18.9 centimeters per second. So that's what they needed for the IFV Pro inlet as well, at 1 liter per minute. So then you kind of reverse calculate, and they came up with a diameter really close to 1 centimeter. So it's amazing how nicely these numbers came out. The IOM is 1.5, and the diameter is basically 1 centimeter as well for the IFV Pro. Now, you can also notice that the IOM is actually a taller device as well. And so that was something else I noticed, that the distance from the opening to the filter was also shortened, and that the ratio of the opening diameter to the depth is 1 in both cases. So 1.5 centimeters across and 1.5 meters of depth to the IOM, and the same with the IFV Pro. So again, that was the thing we couldn't adjust with just taking an OVS off the shelf. We couldn't adjust that filter location, which really would have helped a lot. But we figured, well, you're going to buy them as whatever they are, and you're not going to expect somebody to push that filter upward as this one in a sense is. But in both cases, you see, it's obviously a limiting factor of having to use a 25 millimeter filter. So it turns this into kind of a cup-shaped looking thing for the IFV Pro. Let me just double check. We're at 4:38. Okay. So then we're going to now do the same sort of thing with the IFV as we did before, except we're also going to add a dual phase aerosol to the 2 of them to see how it performs. And in the meantime, I got a new lab with a really cool chamber. So instead of kind of a cobbled together thing, I have this chamber designed just for this kind of purpose of having the inlet aerosol up top, allowing it to come back down through in a nice laminar flow. So that's what we used. Inside, we can line everything up nicely between the different samplers. Close the door. These are solenoids, so we could actuate them from the outside once everything was closed up. And a nice aerosol was coming down through, and then we turn them on. And lo and behold, here's the comparison between the IOM and the IFV. Now, under this system, you see it actually followed the typical convention more so than that dotted line, which I really don't have a good explanation for, but remarkably similar, as you can see here, between the two, and as would be expected, right, when you've reverse engineered the IOM sampling head. However, dig into it as deeply as we did, we found that there was overall a 9% increase. So that's the same as that other diagram I showed you where it said 100%. I'm sorry, I've got it as a fraction here of 1 instead of 100%, but you get the idea. So the IFV Pro actually is oversampling slightly relative to the IOM, but in a sense that's more of a good thing than way undersampling. Okay, and then we developed a 55-gallon drum so we could spray, in this case, some ethylene glycol into it to have these 2 samplers compared that way. And EG was, pretty safe, easy to handle, something we could put in the lab. And it has a vapor pressure right there in the IFV notation range. So it was a good surrogate for an actual pesticide of some sort. And we sprayed a couple shots into it, allowed them to sample, which admittedly is not the greatest when it comes to a circulation of the aerosol in there and mimicking reality, but it was what it was. And so had to use the glycols method 5523 for this. We were happy that the size distribution of the particles were in that kind of range that we would expect from droplets from a hand sprayer. And these are the results. Out of the how many did we do? 8 different trials. 2 of them, the OVS was higher than the IFV Pro, but in general, the IFV Pro, as kind of suspected, was pulling in a lot more mass than the OVS. Matter of fact, there's about, it says 190% increase, so basically double in that case. So the other previous results showed that the OVS was undersampling relative to the IOM by about a third. So it's like a 3-to-1. Here we're showing kind of a 2-to-1 the other way. So somewhere between a 2-fold to 3-fold difference in mass uptake between the OVS and the IFV Pro. So, all things considered, the IFV Pro is a better device, especially if we want that IF part to be associated with it. So here are those conclusions I just mentioned. And again, we were disappointed those simple modifications of the OVS didn't work for us. So just now to conclude, what needs to be done here, and some of the kind of technical or just basic procedural stuff that we ran into. So one issue that may not be, we don't know, for example, when we sent this off to the lab, we had to send the filter and the sorbent tube off separately, of course. And we had to tell them, oh, but this filter goes with this sorbent tube. Please desorb them together. So that's one thing that you have to do a lot more communication. It's not just one device like the OVS. The other thing is, I don't believe they washed out the inside of this IOM-like sampling head, right? So they're not getting the mass of droplets that would collect on there like you would if you weighed it, right, the IOM. The other issue that Mike Murphy brought up is, what about any losses? There's quite a bit of sample train behind the backside of the filter before you get to the sorbent tube material, as versus the OVS, which is a direct transfer. The filter sitting right on top of the sorbent material. So, I think you also would want to work with NIOSH to add this as an acceptable sampler in the standard methods. And so that's another whole thing. Otherwise, I don't know if it's going to be adopted, excuse me. And then this issue of working with the labs to determine the best procedure, how do you want them sent? So, for example, and then there's the issue of the IH themselves. Okay, so this is just general to pesticides anyway. We found it somewhat confusing. Okay, what pesticide am I going to go out there and actually sample for, and then what method is the lab going to use, and then what media is going to be applied to that particular standard method, right? So thankfully, most pesticides will require this XAD2 sorbent material, and that's the OVS-2 of that standard I showed you. That's where the 2 comes from. There's also an XAD-7, so that's the only other possibility there. Thankfully, the manual for the IFV Pro does link this up. They do show you, okay, for this type of pesticide, use this filter with that sorbent tube. So they try to give you some help there, but of course the list is only so long. And yes, NIOSH likes quartz fiber filters and OSHA likes glass fiber filters, and the war goes on. There's also these separate cassettes. Let me see if I can pull this up for you. So here's here's what you're going to order. And it comes with a handy calibration adapter. Here's the instrument itself. And right, this shows the whole instrument, but what you're buying is the little cassettes. See that here's the filter cassette. So you have to buy one for each sample and then ship off this stainless steel cassette thing in its little cassette transport container to the lab. And so the first time we sent them off and never to be seen again, right? So we just assumed that they would send them back. But nope, we had to specifically request, could you please also send these expensive cassettes back to us? So it's all nicely set up here. I'm not knocking that, but there's just these extra little details that have to be done. And then again, you need to make the lab aware to follow up. This is not, you got to tell them this isn't the standard. You're going to expect the OVS sampler to show up, but it's not going to be the OVS sampler. And then again, one kind of neat thing actually is it shows here desorbed together. We paid the extra money to have the filter desorbed separately from the sorbent tube, so you could actually determine what was left over as the droplet phase versus the vapor phase. So that's nice. But again, had to ask them to back, or whereas the OVS is just thrown away. So there's sort of some additional complications for the use of this thing. So we wrote all this up into a paper that was actually given an award. So we're pretty excited about that. And so there is a paper there if you want to get into the more details on this. And right now I've got yet another master's student dutifully getting further into this. So we have found local pesticide applicators, and we've got them wearing both of these side by side in various methods of spraying, including the use of those little ATV with the booms and stuff. The only downside here is that from what we can understand, most people in this area use Roundup, glyphosate, and or this thing called horsepower, which is a kind of a triple combination of compounds. And none of those four are IFV notation compounds. And they're also rather expensive. So if you get into this business, you have to have a pretty hefty pocketbook to, per sample. So this is going to rack up very fast, and stretching the limits of what I can afford to give to a master's student. So we're going to have to limit the number of samples on this. And and he's also, though, kind of redoing the barrel test, as we call it, with a bigger tent with a human form in it and a control pressure sprayer. So we're looking at that as well. And this is all going to be done by Spencer, who's doing an awesome job of making this all happen, because it involves human subjects, research, etc. And just to emphasize again, these herbicides we're working with now, not only do they not have a TLV, but look at their vapor pressures are minuscule. So these should be droplet only pesticides. They're, again, so we got all this going, and yet, to be honest, the IFV type of sampling is kind of overkill for these types of pesticides or herbicides that we're going to be dealing with. But that's
so,
the way it goes.
Patrick?
Yeah.
So just kind of curious, did you explore taking the OVS sampler and possibly using a glass cutter to cut it down to where the opening size is the same distance down to the filter to see how well it would do?
Yeah. Actually, one of the orientations Shawnee worked with was we purposely put the filter up closer to the front end because we could do that. We had a little bit more of that Tygon tubing as kind of a backup to the filter. So you can imagine stuffing tubing in there at a certain length and putting the filter on top of that, and then kind of sealing it down. So we could adjust the placement of the filter. And yes, it did improve things some, But we, in terms of writing the paper and stuff, we just thought as practically as possible and realized, that an industrial hygienist isn't going to go out and cut the glass but it's possible you can get to the manufacturer and tell them that would be the place to do it, right?
That's what I was after was,
Yeah.
if you thought it, was pretty close to the IOM inhalable curve, then you could go back to the manufacturer and say, hey, we need to cut this down. But then I think the other suggestion is, and many people will know that I'm not a super duper fan of the TLB committee and how they do things, but that's the place that needs to they need to provide a better explanation on the IFV and make sure that people do realize it is the inhalable fraction. Because like you said, it's not clear cut.
Yeah, it's not real clear. Yeah, definitely. And it's interesting. It was kind of a chicken or egg thing, isn't it? To declare this notation, knowing that there really is no sampler out there in the world that could satisfy it. Now, there's also a German company. They've come up with something as well. So there are, from my understanding, two such samplers in the world right now. And I'm on this ASTM committee as well that reviews the methods. And so there's a method from ASTM as well getting pushed out, if it hasn't already, that discusses these issues as well. But those are all good points.
So one other thing, just kind of a little slightly off subject, but with the IOM, have you guys done any testing of it with the foam insert? We've gone to using the IOM with the foam insert particularly for welding applications so that we can get the respirable and the inhalable. But it's been, how do I put it? The lab charges us double for the analysis because you analyze the foam separately and the filter separately. And then they add the two together to get the inhalable fraction. But we've definitely gone to that just because trying to put two pumps on a welder doesn't work real well.
Right.
We're still kind of evaluating our results overall.
Yeah, obviously there was some work done on that back in the day now. Gosh, amazing how time is crawling along. In terms of, do you actually get a respirable fraction on the foam? I did a little bit of that, but that would be an interesting project to kind of resurrect that issue. I know from what I looked into that, of course, the longer you sample through it, the more clogged the foam gets, and therefore it becomes more and more of a filter, right? And less and less gets through it. And so that there's inevitably that issue that you'd have to just realize that you're not going to get an absolutely accurate respirable sample out of it. But as you say, convenience, trumps accuracy, I guess, in many cases.
But you also know from the respirable standpoint that if anything, your results could still be biased low.
Okay, right. Yep.
So if you actually are over the respirable amount, that you're still underestimating to a certain extent, and you gotta figure something out for controls.
Kind of more broadly, you showed that the IFV Pro is an improvement. Do you think that it hits enough of a sweet spot, or do you think there's more room for some design improvements that can improve the capture even more?
Yeah, good question. Well, I think they are also constrained by the availability of the sorbent tube types. And so that's getting back to Kent's comment, I guess, so if you could redesign those, you could shorten up that tube length a bit, for example, because it's getting pretty big, pretty long. And interesting, now your sample line tube is coming up underneath your your armpit as versus coming over your shoulder, right? So it's because you're trying to tack onto the bottom of that sorbent tube. So there's a few issues there. But I'll also admit it would be a stretch to try to convince someone that you've got an inhalable fraction sampler any other way than making it a scale down of the IOM, right? I mean, that to convince people that, yeah, that's probably going to work. And actually, as far as I know, that's just what they did. They said, well, it's perfectly scaled, so therefore it works. So,
Yes.
yeah, well, that's a good question, Noah. And there's always room for improvement. Yeah.
Okay.
Well, thanks, Patrick. And good to see everybody. Take care.
Okay, Kent.
You too.
Patrick, one quick question. How's SKC marketing this, or are they?
Don't know in terms of marketing, other than it's on their website, and I'm not sure. They haven't contacted me personally about,
Okay.
but obviously with the paper now, that's public domain. They can do whatever they want with it in terms of verifying its capabilities, from a external scientific approach. It wasn't something in-house done. So
Okay.
I know most vendors like that, right? Because it
For sure.
takes the bias away, a bias problem away.
Now I know Doug wanted to record, right?
Exactly. Right. Yep. Mm-hmm.
Interesting. Okay.
But again, I made that comment about the standard method. So I don't see a wholesale use of it until that the name of that device gets into those methods, and God knows how long it takes to change those things. So I don't know. Yeah.
Interesting.
Mhm.
Okay.
Mhm.
Well, any other questions for Dr. O'Shaughnessy?
Patrick, can you share this presentation? I missed the first part of it.
I hope I recorded everything, and I am going to. The plan is we have a YouTube site for this Center I direct, and so it'll be popping up as a link. So we'll give that to Cindy or whomever to disseminate that around. Okay.
Thank
So,
you.
Yeah, sure.
Give it to Cindy, and she will pass it around to the local section here.
Good. Just wait, probably mid next week or something by the time it gets all set up.
Sounds good.
All right, off to supper time.
Well, yeah, I do want to thank you for your presentation. That was great, and I think just as importantly to me, we got the local section off the ground again for the first meeting. The next meeting is November 1st at